Okay, can you hear me?
Yes, ma'am.
Okay. Good morning, everyone. Welcome to the class of satellite and inertial navigation systems. Since today is the first class, we'll have a course overview. These are the contents of today's presentation. This is primarily a navigation class. So we'll start with the basic definition of navigation. What is navigation? In this context, we'll also quickly look at the relations between navigation, guidance, and control. Often we use these terms interchangeably. So we'll quickly look at their differences. And then we'll have a course overview. In particular, we'll look at approximate breakup of lecture contents and uh, again, this is approximate, so I'll just give you approximate idea of what you are going to learn in this course, in the course overview. Then I'll give you some references which you can look at alongside the class lectures. This is an advanced course, so don't think that whatever I will tell in the class will be available in books straight away. That is not possible. Uh, so you need to first attend the class and then only you can look at the books. Okay. Then we'll discuss the grading policy and finally, if we have time left after discussing all this, we'll get started with some terminologies pertaining to navigation. Okay. So with this, let's start with the definition of navigation. So in particular, we are also going to properly define navigation and guidance, these two terms on this slide. And on the next slide, we are going to see navigation, guidance, control as a system. Now, what is navigation? So basically, navigation answers questions like where an object is located relative to some coordinate frame. Okay. On the other hand, guidance gives instructions on how to move from the current location to the desired one. So with the help of navigation methods, we find the current location, the position of the object, and then using guidance algorithms, we go to the desired location from the current location. Okay. Now, according to the concise Oxford Dictionary, navigation is any of several methods of determining or planning a ship's or aircraft's position and course. Course is basically trajectory here. Uh, by geometry, astronomy, radio signals, etc. So this is the definition that you will get from the dictionary. Now this definition has two concepts, science and art of navigation. So let's see what are they. The science of navigation involves determination of the position and velocity. It's not only position velocity, there are other quantities also that we can determine, and you will see that later. For the time being, just consider position and velocity. So science of navigation involves determination of position and velocity of a moving body, not necessarily a moving body, it can be stationary also, of a body with respect to a known reference point. Okay, it is always with respect to some reference. So that is science of navigation. Whereas art of navigation is about planning and maintaining a course from one location to another in such a way that we avoid obstacles and collisions. So art of navigation is also called guidance, which we defined earlier, pilotage or routing. Okay. Now in this class, we are concerned with the science of navigation, which is simply called navigation. So by navigation, strictly speaking, we refer to the science of navigation. Okay. And art of navigation is basically guidance. So with this in mind, here we have a simple block diagram of these three important blocks: guidance, navigation, and control. Now, we are actually interested in this block in this class. Okay, so this is the navigation block. Inside the navigation block, we have sensors. Okay, so sensors basically measure some parameters or quantities. They send some quantities, they make measurements, and those measurements are fed to the navigation algorithms. Okay, then the navigation algorithms process these measurements to output position, velocity, orientation, etc. to the subsequent guidance block. Now, guidance block has information about desired location or orientation of the body you are interested in maneuvering or controlling, and it generates necessary instructions on how to get there. And these instructions are fed to the control block, and then control block has the responsibility of implementing them. So it generates necessary outputs and using actuators. Here I have not shown actuators separately. So using actuators, it maneuvers the vehicle to the desired location. Now here we are interested in controlling the vehicle. Now it can be any system. It can be a living being also. For example, if we consider the human body, there also we have all these three blocks. So we have 5 sensory organs, right? The eyes, ears, nose, tongue, and skin. So using these sensors, we sense things, and then our observations are sent to the brain. So in case of human body, all these navigation, control, and guidance blocks, the algorithms reside in the brain, right? So the brain does all the things, and then finally, using hands, legs, and necks, we maneuver our body, move our body, right? So it need not be a vehicle, it can be a living being also. Now, in this class, as I said earlier, we are interested in this block, navigation block. So what exactly are you going to learn in this class? So you will understand the basic principles behind navigation. You'll also have a working knowledge of satellite-based navigation. And then if time permits, you will have an introductory knowledge of inertial navigation. Now, I'm not sure whether we'll be able to manage time for inertial navigation. If we have some time remaining towards the end after discussing all the things, we'll have an introductory discussion of inertial navigation. Okay? So, any question up to this point? Okay. So here we have, yes, any question?
No, ma'am.
Here we have the approximate breakup of lecture contents. So this is a 4 credit course. So you have 3 lectures and 1 tutorial class. But it may not happen that every week we'll have tutorial class. Generally, Friday's second class is reserved as tutorial class. But sometimes we may have some theory part to be completed before tutorial. So we'll do that and then we'll have tutorial. So in the first class, we are having introduction and we'll also define some basic terminologies pertaining to navigation. Then in approximately 2 lectures, we are going to cover, we'll have an overview of different navigation techniques. So approximately 2 lectures for this. Then navigation coordinate systems and earth surface models will be covered in 2 lectures. So we cannot straight away get into satellite navigation. Okay, we need to prepare the groundwork. Without having the groundwork, it is not possible to get into the main part of this course. So we need to spend quite some time to build the foundation, and initially, starting from today, we are going to do that. So we'll discuss different navigation coordinate systems and earth surface models. Then we'll have a discussion of attitude. Again, all this will be at the top level. Now in attitude, we are going to see some methods to determine attitude. For example, coordinate transformation, Euler angles. We'll discuss in somewhat detail. Then quaternions and rotation vectors we will not discuss in detail. We will just have some discussion at the top level. Approximately 3 to 4 lectures. Again, all these are approximate breakups, and also the tutorial classes are included in this. Okay. And I'll also give you, as we discuss different topics, I'll also give you some homework problems, and you are expected to do the homework and then tell me in the tutorial class how the problems should be solved. Now, after all this, we are going to move to a different topic, which is filtering and estimation. See, in navigation, we are interested in determining something based on some measurements, right? So whenever we make some measurements, automatically some errors will get added to the measurements. So we cannot have true measurements, basically. Accurate measurements, 100% accurate measurements. Some errors will always be there. So our objective is to eliminate the error to the extent possible and extract useful information. For this purpose, we need to use a filter. So navigation is not possible without a filter. Therefore, we'll have introductory discussion of filtering and estimations. We cannot straight away get into filter. We also need to first define suitable models for representing the errors in statistical terms. We'll quickly do that, and then we'll discuss some important filtering methods. So these are all software filters, basically algorithms which eliminate these errors termed noise to the extent possible and provide useful information. They are called filters or estimation algorithms. Now this can be a separate course altogether, but we are going to look at it at a very high level so that you understand why filters are required, and at a very top level you also understand how filters are implemented. Okay, so after all this only we can start with the discussion of the main part of this course, which is Global Navigation Satellite Systems or GNSS. So about 20 to 24 lectures we'll have on GNSS. I'm sure all of you know about GPS, the Global Positioning System of the USA. That was the first GNSS system developed. Okay. Now different countries have their own systems. Some are operational, some are under development. So all these systems, GPS-like systems, are together called Global Navigation Satellite Systems. Okay, GNSS. So we will have a detailed discussion. Again, not too detailed. We cannot have highly detailed discussion. Approximately 20 to 24 lectures are allocated for the discussion of global navigation satellite systems. And then if we have some time remaining, we'll have an introductory discussion of the inertial navigation system. So these are two primary navigation systems, GNSS and INS. Okay, when we discuss different navigation techniques, you will have an overview of their operating principles. They complement each other. And that's why the usual strategy is to combine them. So we'll also talk about integrated navigation systems at a very top level while talking about different navigation techniques. And in this context, I will also share with you a video where you will see a novel application of GNSS and INS. It's very interesting. So basically, it's about flying an aircraft through a hurricane to get all the useful information about the hurricanes. And this enables accurate determination of the hurricane path so that people can be evacuated well in advance. So in that video, you will get to see how they use GNSS and INS to fly the aircraft right through the hurricane. Okay, so such missions are conducted by NOAA, National Oceanic and Atmospheric Agency, based in the US. Okay, so the presentation is given by a NOAA, a navigation engineer. So he discusses all the things, issues that they need to handle. They basically fly the mission, so they are really brave people because they will be on board the aircraft to fly the mission. Um, there are many other applications, but I want you to see this video particularly because it's quite interesting. As an aerospace engineer, also it makes things a lot more interesting to see how they fly the aircraft right through the hurricane. Okay. Next, course material. So in this class, we have one textbook by Paul Groves. I'm going to follow 2013 edition, but in case you cannot get 2013 edition, you can also read the 2008 edition. Okay. Uh, Again, this it's not that I am going to follow this book chapter wise. That is not possible. Uh, but most of the things that I will talk in this class can be found in this book. But it's quite a detailed book. People in the navigation community, they prefer this book because it has all the things in one place. Okay, but for a beginner, it may be a little difficult to get started with unless you attend the class lectures. Okay. Then there are other references also. This is a very good book for a beginner. It describes things in an easy manner, and then other books are also good to get. Um, so alongside the lecture material, the class notes, you can refer to these books if you want to get more information about the topic. Now, regarding filtering and estimation, I have not included any book. As I told you earlier, it's a different subject altogether. So, for filtering and estimation, you need to rely on the lecture material. Okay, I cannot refer any book for that because any book will have a lot more detailed discussion, and if you start reading from them, there is a high chance that you'll get lost. Okay, and this course is not meant for filtering and estimation. It's a navigation course. So we are learning filtering and estimation at a high level so that we understand the context in which these algorithms are used in navigation. Okay, and then these are available online. They actually give details of these two constellations. In this class, we'll not be able to talk about different constellations, different systems, GPS-like systems. So we'll mainly concentrate on GPS and IRNSS. IRNSS is the constellation being developed by India, Indian Regional Navigation Satellite System. It is also called NAVI, Navigation with Indian Constellation. So these interface control documents are available online. We give you details, specific details about these constellations. Okay. Here we have a link to GNSS tools. Now, you may ask why it is required. In this class, we have a mini project, okay, where you will have to log raw GNSS data using an Android phone. Okay, and then you also need to process the raw GNSS data to get the final output, position, velocity, etc. So this will give you a feel for what we are going to discuss. Everything that we are going to discuss under GNSS is very much real. Okay, so it's not abstract. So getting, collecting some data and processing that will give you some idea about the whole thing, and it will also improve your understanding. So that's why I have kept this mini project. Uh, in offline classes, actually, I ask students to form groups and do the project in more detail, but in online class, it's a little inconvenient. That's why I have, instead of having a full-fledged project, I have kept a mini project. Okay. Um, Now, in this link, you will get all the details about the app that you need to install on your smartphone, and also the software package that you have to install on your laptop. Okay. Now, all the phones will not allow logging raw GNSS measurements. Um, Phones which were manufactured 2016 onwards can only log raw GNSS measurements. So you need to find the hardware year of the phone. Either you can get that information from the shop where you purchase it, uh, or what you can do is you can go to that website. There they have given list of phones which uh, can log raw measurements. If you do not find your phone there, you can install that app. Installation of the app on the phone is quite easy. So you can install that app on your phone, and then once you open the app, on the bottom left or right, you will get to know the hardware year of your phone. Okay. Now I could not do it because my phone was manufactured in 2015. When I installed that app and opened it, I found that the hardware year was written as 2015. So I could not log. But if you purchased phone later, after 2016, 2017, 18, later 2016 means there's a high chance that your phone will allow you to log GNSS data. So in the mini project, the first thing that you need to do is to go to that website and download the app. Okay, install the app and see the hardware year of the phone in case you do not know the hardware year. Okay, the hardware year is different from the Android version that you get. Okay, so you need to particularly know the hardware year when the phone was manufactured. Uh, and then the software package which will allow you to process the raw GNSS data also has to be installed on your laptop, and do not do it at the last moment because nothing will work. I have seen that different people face different problems. There is a forum also on that website where you can post questions. So unless you do it well in advance, it is difficult that you can make things working at the end. Um, uh, yeah. So, while discussing navigation techniques, I'll also give you overview of GNSS, some important terminologies I will explain there, so that once you visit that website and see more details, you do not feel lost. Okay, because you will know those terminologies and you will not have any problem with the things that are described here. But do not keep it for the last moment. You should start this as soon as possible. Okay. Next is grading policy. In this class, we will have 4 class tests. Okay, each contributing 20 marks. So total 80 marks will come from 4 class tests, and the test dates are also given here. 4th February, 24th February, 17th March, and 13th April. So these are the test dates. In case there is any change, I'll let you know well in advance. But as of now, these are the dates when the tests will be conducted. Okay, and then the rest 20 marks will come from class participation and the project that I mentioned. How the marks will be given? So to get full marks, you need to do the following. You need to regularly attend classes. You also need to be interactive in the classes. So should ask questions, answer questions, and then of course you should solve the homework problem. So I'll give you some homework problems as we go on, and you should solve the problems, at least try to solve the problems, and then discuss things in the tutorial class. And then the mini project is there, so where you need to log and analyze real GNSS data using smartphones. The project presentation will be held on 25th February. Okay, so 25th February is a Friday, and we'll have project presentation. Each person will get some 10 minutes time for the presentation, and present the results. So each person has to collect raw GNSS data using the software package, analyze the raw data, and present it. So analysis does not mean that you just do some mechanical things and show the results. So I will actually ask you questions, and you should analyze things and then be able to answer questions. So it's not just that you do things mechanically, you install the app, and then install the software package, get some data collected, and just put in the software and get some results. Not like that. You should also analyze the results. Why you are getting these results, in what kind of environment you have collected data, how many satellites are visible, what is the quality of signal, what kind of outputs you are getting. All these things you need to analyze and then explain in the presentation. Any question? Everything is clear?
Yes, ma'am.
Okay, so let's discuss some terminologies pertaining to navigation.
Before that, further explaining how to.
Sorry?
You'll be further explaining how to do the project, right?
You will get all the information on this website, and I'll also explain different terminologies that you will come across in that website. Okay, but yeah, information about installation of app and the software package is available on that website. There is also a forum where, in case you face some issues related to your installation, you can post questions, and of course you can discuss in the class. Okay, so does this answer your question? Yes or no?
Yes, ma'am. Hello.
Yes. Any other question? Okay. So let's discuss some terminologies related to navigation. Navigation involves determination of position. So earlier we mentioned only position and velocity. So it has other quantities also. Position, velocity. Velocity need not be only linear, can be linear and angular velocity. Acceleration, linear and angular, depending on what sensor you are using, what system, navigation system you are using, you may or may not get both linear and angular. Okay, so position, velocity, acceleration, and attitude. Attitude is the orientation of a body with respect to a reference coordinate frame. Okay. Now, there is one more term called positioning, which is related to navigation. It's basically a subset of navigation. Okay, so positioning actually means determination of position. Okay, so this is a subset of navigation. There are applications where we are particularly interested in position. We do not want this acceleration, velocity, acceleration, and altitude. For example, surveying. In surveying, we are interested in precisely determining boundaries of an object. So here we want to know the position with high accuracy. Mapping. Then location-based services. What are location-based services? Location-based services are those where you get the service depending on your location. For example, suppose you have gone to a new city and you are out of cash. So what you need to do, you need to locate a nearby ATM. So what you do, you find out in your cell phone the places of where the ATM are located around you, right? So for that, GNSS is actually used because GNSS gives your current location, and then based on your current locations, all the places are shown. So such services which are provided to you based on your location are called location-based services. Okay, so here you are interested in only position. Okay, you are not interested in velocity, acceleration, teaching. So positioning is basically a subset of navigation. Now there are different ways we can classify positioning. This classification that I have shown here applies to navigation as well. Okay, so whatever classifications we'll discuss, although it is written in the context of positioning, it applies to navigation as well. So there are three categories. The first one is based on how we process measurements. Measurements can be processed in real time. It can also be processed offline, which is called post-processing. Example of post-processing is surveying. So in case of the mini project, you will log raw GNSS measurements and then post-process the measurements using the software package. So this is an example of post-processing. You are not processing then and there. You are processing it after some time offline. Now when you use the same app to get your position in the phone, that is called real-time processing. Okay. Now real-time processing can be continuous. It can also be one-time processing. So generally if the object is moving, we are interested in continuous real-time processing. And one-time processing is needed when for a stationary object. Just once you need to, suppose you are standing in front of some place and you want to know your position. So only once you determine the position, but you want that position at that time only. You do not want the position after 10 minutes or 15 minutes. Right? The next classification is based on the kind of object that is navigating. So it can be a fixed object. For example, in survey applications, we are interested in finding boundaries of places. So there the objects are fixed. It can be a moving object also. For example, any vehicles you take will be a moving object when it is moving, right? The third classification is based on where you are doing the processing. Whether you are doing the processing on the object itself or remotely. It's called self or remote. Self means the position is calculated or navigation algorithms reside in the object itself. So sensors make measurements and algorithms will process the measurements in the object itself. The example is car navigation, pedestrian navigation. So when you are navigating with a cell phone, so in the cell phone you have all the things, right? And you get measurements, you do processing. I mean, the cell phone does everything and finally gives you the position. So that is an example of self navigation or self positioning. Then in case of remote positioning, this processing is done remotely. The example is radar surveillance by ATC. So radar will track aircraft and do processing and then finally give the aircraft position to the ATC. So here we are doing it remotely. So for tracking an object, generally we go for remote positioning. Okay. Next, navigation system. Navigation system is a device that determines position, velocity, etc. The examples are GNSS and INS, Global Navigation Satellite System. Okay, GNSS is not a device, it's much bigger than that. INS you can call the device, Inertial Navigation System. The navigation sensor is a device that measures a property or a quantity from which the navigation system gives position, velocity, etc. In case of GNSS, the user equipment which the user uses to get GNSS signals is called GNSS receiver. In your cell phone, you have a small chip as a receiver, so that is called sensor. Then in case of inertial navigation systems, we have accelerometers and gyroscopes. Those are sensors. Okay. So they make measurements. And then these measurements are processed by algorithms to give navigation solution. Outputs of a navigation system are called navigation solutions. So outputs could be position, velocity with linear, angular, acceleration, and attitude. Okay. Next is position versus location. So we use this both, right? Position and location. Now, can you think and tell me what could be the difference between these two, position and location? I'm giving you some time to think about, and then tell me the difference. We'll stop at that point. Okay. Tell me the difference between these two terms. Are they the same or they are actually different? What do you think? What do you think? Position versus location.
Ma'am, maybe position gives the orientation of the object and location gives the coordinates of that particular object, like the exact coordinates of that object with respect to origin.
No, position
And
is different from orientation. Position and orientation are not the same. Okay. Position means, okay, I'll not tell you, but only thing I can tell you, position and orientation are not the same. Okay.
Ma'am, location with respect to the Earth reference
Hmm?
frame.
With respect to
Earth,
art,
Earth reference
position also
frame
you can have
means
with respect to art.
yes.
For terrestrial positioning, it is always with respect to art. Then
when you say location, are the surroundings also included?
surrounding,
The surroundings are also the place, the entire place is also included.
and then what is position? Surrounding the place. So can you give an example? What do you mean by surrounding the place?
Ma'am, as in I'm not sure if I'm right. Maybe like if we
So
are at a
think
particular
about that.
place,
Think about that. Yes, yes.
maybe if we are at a particular place, our coordinates like refer to our position, but even if we move from that particular place, that
But
place refers to the location.
but what do you mean by place? In position also you have to be in a particular place only, right? So you are on the right track, but you need to be more precise. There is a subtle difference between the two terms, okay? Position and location. We often use them interchangeably, but while using them, we do not use the same description. So what is the difference between the two?
Ma'am, maybe position is with respect to other objects and location is with respect to a common center origin.
How can that be? Give an example.
Like if we have three cars, we can say the middle car is positioned between the two, whereas in
Hmm.
location will tell the actual GPS points.
Is it?
I'm not sure, ma'am.
Think about it. Position versus location. Nilay, are you here?
Ma'am, position, I think position of an object means we give the coordinates of that particular, we can get the coordinates of that particular object. And location means we will tell in which place it is exactly located, like the way in what surroundings it is.
Okay. So what is the example of location?
Suppose now I want to go to a restaurant. Now
Hmm.
I can say from my home.
Hmm.
So my position will be like some coordinates, XYZ coordinates, and
Hmm.
location I'll tell some place or there like mm,
Your
AV
address
Road,
will be your
AVR Road.
location.
Yeah,
Address will
yeah,
be.
something like I think so.
Yeah. So basically, one is quantitative, the other one is qualitative. Okay.
Yes,
Position is
yes.
Nanda was on the right track. She also, I think, wanted to say something similar, right, Nanda?
Yes, ma'am.
Yeah. So position is actually quantitative. Okay. So yeah. So when you say position, you would say latitude, longitude, height, like that. Okay. And then location is qualitative. So you will tell your location with respect to some road or building, okay, some landmark. So your address is your location, okay. Whereas latitude, longitude, height that you get using a navigation system like GNS is your position. That is not location, okay. Then the position is projected onto a map in the phone to give you your location. In the map, you get your location actually. Generally, you get your location. Okay? But the navigation system does not give you location. It gives you your position, and then that position is projected onto a map, built-in map, to give you your location. Okay? So this is the basic difference between the two. Um, so that's all for today. If you have any question, you can discuss that. Otherwise, we'll close at this point and we'll continue tomorrow.
Ma'am, can you call the position? Position is also called as a location, or
How? I told you the difference between position and location, right? So in
yes,
positioning, you are
yes,
getting
ma'am.
position, right? So you can always go back and forth between the two,
Okay.
provided you have the right algorithm. One example is you get position using navigation system and get the location by projecting it onto a map. Okay? So from position, you can easily find location using a map. Any other question?
No, ma'am. Thank you.
Okay, so that's it for today. We'll meet again tomorrow.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.